Good morning, students. In our last lecture, we have seen types of physical quantity. There is two types, a scalar and the vector. Scalar means only described by magnitude, and vector means it can be described by magnitude and direction both. There needs two things, a magnitude and the direction in a vector, while in a scalar only need of magnitude, right? Not only that, we have seen a distance which is easy to understand a scalar quantity, while a displacement is easy to understand a vector quantity. So we have seen two examples of distance and a displacement, or we can say that it is two examples of a physical quantity. For scalar, the distance, and for a vector, a displacement. Right? Today we will study about what is the difference between this distance and the displacement. We have seen it in the last lecture. A distance can be only described by a magnitude, while the displacement can be described by the direction and the magnitude both, right? But we will study here a difference between distance and displacement, because it can be asked in your exam for 2 months. Okay? So the question is, what is the difference between distance and displacement? So first of all, at here distance, and another part displacement. The first thing in difference is what? The definition. Right? The first one we have to take a definition of both of them. So first of all, for the distance, total part covered by moving object is known as distance of that object, and the displacement, minimum distance from initial to final position is known as displacement. So first one is the definition. Now the second one, it is scalar quantity. Here it is a scalar quantity. While actually it is vector quantity, which you have seen in the last video, right? Now the third one is there, distance never be zero for moving object. As you know that if an object is moving, then its distance never becomes a zero. At here one object, if it is moving, then it always covers some of the distance. If it comes back on the same position, after that you have to take only the summation of it, and just because of that, distance can't be zero, right? While on displacement can be zero. When we can say that the displacement is zero, when object comes back on the initial position. If an object is moving from here to here, then it comes back on the same path and on initial position. As you know that it is a minimum distance from initial to final position. If the initial and the final position both are same, only at one point, then you can say that the distance between both of them is 0. So displacement becomes a 0. Minimum distance. If an object is moving from here to here, what is initial? Here it is the initial position. Then it covers circumference of a circle and just comes back on the same point. So you can say that here it is, right? On the same position. Initial and the final position, both are same. If both the position is same, then the minimum distance is 0. So displacement can be a 0. Understand? Fourth, distance can be higher than displacement. But the displacement never be higher than distance. Remember that. As you know that distance is the total path, while the displacement is the minimum distance. So always minimum is less or equal to the total one. If object is moving from A to B, B to C, distance is 3. What is the total distance? 6. And what is the displacement? Initial and the final position. A total distance is 3 plus 3 is equal to 6. So it can become equal. But if object is moving from A to B, B to C and C to B, then the total one is 9. While the displacement is initial to final. Initial is A, final is B. So it becomes only 3, which is less than 9. So you can say that at here, according to this, the displacement can be less than the distance, but never becomes higher than the distance. So here it is the 4 points of difference for the distance and the displacement. Now, we are going to study about some of the sums related to the distance and displacement. Okay. Now we will see the sums. Okay. We have to calculate it. Okay. The first one. Part of. Okay. Just one object. One object is moving on a path as shown in figure. Right? There is one path which is shown in figure, and the object is moving on it. Okay? If object is moving from point A to point B, and then going to point and then goes to point C. Calculate distance and displacement. Okay. First of all, we have to there is one question. In this question, the path is given to you. So I am giving you a path, right? Object is moving on this straight path. Okay? Here it is point A. Here it is point B. And here it is point C. If the distance between A and B is 10 km. Distance between B and C is 7. Now you have to calculate the distance and the displacement. Now the distance. Distance is equal to total part. What is the total part? Object is moving from A to B, so AB. Then it gone to the C. So B to C. A to B, then it goes to B to C. Okay. What is the distance between AB? It's a 10. While between B and C, it's a 7. So what is the total distance? It's a 17. So it's a 17 kilometer is the distance. Now displacement. What is displacement? Minimum distance. From initial to final position. Which one is the initial position? A. Which one is the final position? C. The distance between A and C. What is the distance between A and C? A total. It's a 17 kilometer. Or if you can't recognize it as 17 kilometer, then for this one I am going to another trick. Or only for displacement, okay? Displacement. How can you calculate it? Object is moving from A to B. So take it A to B. Then B to C. Okay? Just then it stopped. Right? So A to B plus B to C. There is no written part here. So you have to take both of them as a positive. If it runs back, then you can take it as a negative. So here a 10 plus here a 7. So it becomes 17 kilometer. So like that, you can calculate this sum, okay? So here it is a one sum. Okay. Now, if I am giving you another thing that here. Okay. One object is moving on a path which is shown in figure. Okay. If object is moving from point A to point B, then it gone to the point C and return back on point B. Calculate distance and displacement. Same figure. Okay, now at here what's happening? First of all, we are calculating a distance. Okay, what is distance? Total path. What is the total path? Just see here. If object is moving from point A to point B, so A to B, AB, plus, and then it gone to point C, so B to C. If it comes from A to B, then it just going to be C, then the B to C, so you have to take it as a BC. Then it returns back on point B, so from C it returns back to the B on the same path, so you have to take it as a CB. Okay, you have to take a total path. At here, as you know that distance is a scalar quantity. You does not need to describe a direction here. You have to just take a magnitude, a value only. Okay, so here AB means 10 kilometer. B to C is a 7 kilometer, and C to B 7 kilometer. It returns back. After that, you does not need to take a direction. You haven't used a direction here. Is it in this direction or this direction? We don't care about it. So you have to take only the distance, which is 7. Right? C to B is also 7. At here B to C is 7 and the C to B is 7. So total is, what is the value? 24. Right? So the total distance is 24 kilometers. Now displacement. Minimum distance. Minimum distance from initial to final. What is the initial? It's A. Object starts moving from A and it ends its journey to B. So you have to take only A to B. What is the distance between A and B? It's a 10 kilometers. So you have to take it as a 10 kilometers. Or you can calculate this displacement by this also. It goes from A to B, A, B. Then B to C, B, C. Then C to B, C. Okay? AB. AB means 10 kilometers. BC means 7 kilometers. And CB. At here, displacement is a vector quantity. And for a vector, you have to describe it with the direction. If we take in this direction as a positive, then the another one in opposite, then you have to take it as a negative. We have taken a 10 and a 7. When it goes in this direction, we have taken it as a positive. Then when it returns back, you have to take it as a negative. So BC is 7 and the CB, which is returns back, you have to take it as a negative. So minus 7. Right? So 10 plus 7 plus or minus 7. So it gives you a 10 kilometer. Like that, you can calculate a displacement. Understand? So here it is a 2 questions which you have seen today. Understand? Okay? Now, I extend it. Okay? When object is moving on a path which is shown in figure, if object is moving from point A to point B and then gone to point C and returns back on point A, and finally calculate distance and displacement. Now you can easily understand total path. It goes from A to B, then B to C, then C to B, and finally B to A. A to B, B to C, C to again B, and B to finally comes to A. Okay, so it's a 10 plus 7 plus CB is 7 plus BA is 10. Okay, so what is the answer? 34. It's a 34. Now displacement, minimum distance. What is the initial position? It starts from A and finally it reaches to the A. So the minimum distance is AA. What is the distance between A and A? It's a 0 kilometer. Or you can take it here like that. AB plus BC plus CB plus BA. What is AB? AB is 10, BC 7, CB returning part, so minus 7, and BA it's also in an opposite direction, so minus 10, right? At here we are taking this direction positive and this direction as a negative, so it's 17 plus or minus minus 7 minus 10, so you get 0 kilo. Understand? So here it is, one another example. Now, if you take one another, at here, one object is moving on a path which is shown in figure. If object is moving from point A to point B and then it goes to the point C and returns back on point B and finally comes to point A. After that, in same direction, it reaches to point B. Then calculate distance and displacement. Okay? At here, one object is moving on a path which is shown in figure. If object is moving from point A to point B and then it goes to the point C and returns back on point B and finally comes to point A. After that, it reaches to the in a same direction, means in a returning path. It just reaches to point B. Then calculate distance. So in the same direction, it just reaches to the point B. If we are taking here as a point B, and the distance between both of them is taken as a 2. What is the total path? A distance. What is the distance at here? A to B, B to C, C to B, B to A, and finally A to D. 10 plus 7 plus 7 plus 10 plus 2. It's 36 kilometers. And the minimum distance. What is the initial position? A. What is the final? D. So it's A. What is the answer? You can say that 2 kilometers. It's a wrong answer. Not a 2 kilometer. It's a minus 2 kilometer. Why? In opposite. AB. Not AB. It is not in this direction. So you can take it as a positive. It's in a opposite direction. So it's a minus 2. Or you can easily understand by this one. A to B. B to C. C to B, B to A, and A to B. For AB, 10, at here 7. CB is written in 1, minus 7 in opposite direction. Okay. BA is also in opposite, minus 10, and AD is also in opposite, minus 2. So 10 plus 7 plus or minus 7 plus or minus 10 plus or minus 2. So 7 cancel out, 10 cancel out, and you get minus 2 kilo. Understand it? Okay. So here it is one example in which you get the displacement as a minus. So we have seen 3 types of example in which you get a distance which is always positive, right? Which is always positive. While the distance can be a positive, 0 and negative also. Displacement can be a positive also, 0 also, and negative also. Not only that, we have seen one another thing. In first example, you can see that the distance and displacement both are same. While in the second one, distance become higher, displacement become lesser than it. Okay, less than this distance. Okay, after that it just decreased, right? It never becomes higher than the distance. So from this example, we can say that displacement now becomes higher than the distance. Distance can be higher than displacement or can be equal, right? Okay, but the displacement can be a positive, 0 and negative, while distance is always positive. And if object is not moving, then you can say that the distance is a 0. So it never becomes a negative. Some another examples related to it I will teach you in a next